I recently open sourced this tool I built. It's called Leap. And what it is you can prompt and it will create a 3Blue1Brown style video for you. If you don't know who 3Blue1Brown is, he has probably one of the best math explanations on YouTube, has a massive following, and he uses a library called Manim to render all the animations you see on screen. And so obviously since ChatGPT came out, people have been wondering if all these LLMs can write Manim code and they can produce videos like that without having to write code. And although I've seen some attempts at doing that that are open source, most notably this one, Generative Manim, if I've used their tool, and I just was not happy with the end result because I asked like why sky is blue. It generates a video. It's only 14 seconds. Kind of doesn't make a lot of sense. But anyway, I created one. And again, this is just an alpha release, so it does have a few kinks, but it does work. So it's mostly like a working proof of concept. You can ask a question and then pick the explanation level. Right now, only 2 are enabled, normal or like explain like I'm 5, and then put your email because it takes a couple minutes to generate the video, and then you can just click on that. And then what's going to happen is that within a couple minutes, you will get a notification on your email saying your video is ready, or if you just want to wait and hang out here, that's fine too. But I open source all the code because I would like to, for other developers to contribute, fork, get some ideas from here. Yeah, keep building something cool. By the way, who am I? My name is Sid. I used to be a physicist. Loved it. Will always love physics. It's the love of my life. Love teaching, but academia is dysfunctional. And so plus it didn't pay anything, so I quit. Then I became a corporate slave. My paycheck increased like 4 or 5-fold immediately, but again, not intellectually stimulating enough. So I quit that last year, and now I just build cool shit and get paid for it. So that's what I'm doing now. Anyway, the goal today is really to just kind of show you how to, I mean, even though all the code is like here and you can see exactly how it's done, it's like production ready code. And what I'm trying to do with the series of videos is to create some notebooks where I can show my thought process and kind of just like help you build a basic version of this from scratch. And we'll talk about all these different ideas, like when to do prompt engineering, when to tune the prompts, when to think about fine-tuning the model, when to introduce RAG, how to think about MCPs, and how to integrate tools. And we'll do that without like this heavy use of abstraction frameworks like LangChain and Llama Index, or what have you, because what I've seen, especially amongst like new developers in AI, is that they often think that like you can't build anything with AI unless you use one of these abstracted frameworks, and that's really not true. So today let's just do this in Colab, and what we're going to do is build a basic prototype of Leap from scratch, and I'll show you step by step how to connect APIs and even build like sort of like a quote unquote agentic framework with just purely from scratch, and we won't use anything. By the way, in my code I do use LangGraph, and I do have certain workflow that's orchestrated in LangGraph, and maybe we'll do that in the next notebook, but I just want to show you today how to do these things without any of those abstracted frameworks, right? All right, here we go. Okay, here we go. We'll start in Colab Notebook. I'll post a link somewhere. But Manim does require a lot of complex dependencies. And so unfortunately, you do have to spend a couple minutes just running all of these system level dependency installs. But it doesn't take that long, and you will have to restart your kernel after you're done with this. And then the only required packages we have is OpenAI, obviously for the LLM calls, Pydantic, so we can enforce schema for the structured outputs. We'll talk about that. VoiceOver for doing voiceovers in Manim, because when you produce videos, you want narration as well. And then for some reason, NumPy doesn't play well with the rest of the setup I have. So we have to pick a version of NumPy that's less than 2. Anyway, you need API keys. The way to manage API keys, at least in Colab, is essentially this like key tool. You can put your API keys here. You don't need all of these. The only one you really need, for at least for this notebook, is just the OpenAI API key, right? And then let's kind of go through my opinionated take on how to think about these, AI applications or whatever. Now, let me just clear out one thing. I know there's like 50,000 definitions, but AI at its core is just fancy process automation. That's all it is, right? And so there's a certain process and you're trying to automate it somehow, or at least parts of it. And so when you think about that, you should first focus on how is the task that you're about to do, like how would it be done manually? If you were just doing it yourself, how would you do that manually? And then pick those pieces and see which one of those you can automate. And maybe you can just automate the whole workflow. Maybe you can automate first parts. But like, if this is how you build, I think you will have much more success than the other way, which is like just taking the whole massive task at once and trying to figure out all these like complex setup. So in this series of notebooks, this is generally the steps that we're going to follow. I think we're going to focus on the first 2 today, and then in the future notebooks, we'll do the other thing. So today, at the end of this video, you will have a system where you can just prompt and it will create a video for you. And then down the line, we will iterate and improve and add RAG and think about MCP and design evals, write some tests, then refactor, do some prompt versioning, and then just like deploy. But let's focus on the first 2. And so here's the little visual flow chart of how things are going to go. And this is like probably the easiest workflow that you can think of. The one that I've deployed has a few extra moving pieces, but let's keep it simple. Let's just like start, we're building it from scratch. Let's keep the simplest control flow that we can think of. And then we'll put that in code, see how it works, and then learn a few lessons and then improve upon it. So the way we want to build it is that you will send a prompt, could be any question. Let's say you ask, explain quantum entanglement, right? And then on the first node, obviously, like LLM is not going to know what Manim code to write. So it would be ideal if you can build out a storyboard or like a scene plan where the LLM has an idea of what to animate and like how to explain these things best. And it can generate this like lesson plan where it says like a scene 1 do this and scene 2 do that, and then animate this and then fade that and blah blah blah. And then that gets passed to the next node where now it knows what, how to animate these things, and so it can write the corresponding code. Obviously, none of this is trivial because like how is it going to know all these things? But we'll talk about that. And then obviously, once the code is written, you want to run it. You want to execute it. And if it executes, great, you got a video generator. But often what's going to happen is that the LLMs are going to make like simple mistakes. They will use wrong attributes, maybe use the wrong class sometimes, maybe, some of the methods might be wrong. And so at that point, I think it's ideal to have an error correction node so that if the execution fails, we can pass the error to this error correction node, which has the information of the original code and the errors that it got. And then we'll connect this to basically an LLM, right? And be like, hey, here's the code, here's the problem, can you fix it? And then it fixes it, we'll try to execute it again. Hopefully this time it executes and generates a video. If not, we can see what the new errors are. We can run this loop, maybe let's say put like three times or something. And then if it still doesn't do it, then obviously we got other problems that we should fix. But often this has worked out. And so we'll just keep it simple. Let's just start with basically the first node. So the plan is we're going to build the first 2 nodes, lesson plan and code gen, and then we're going to build these 2, and then in the end, we'll just connect it all together, okay? Now, when you are building the plan C node, to the extent possible, every time you use LLMs, try to get structured outputs. And so what do I mean by that? If you go to, can you see this? This is OpenAI structured outputs. Now, before OpenAI had structured outputs, you have to, there were ways that you can get structured outputs using either like LangChain, or people had like other libraries like Instructor and stuff. And some of those could still be useful in some ways, but I just like to use the API directly, and it has worked out well for me. And yeah, so basically structured outputs is a way so your model always generate a response that adheres to a certain JSON schema, right? So if you just look at one of these examples, if you use the OpenAI client and ask it to, I don't know, extract the event information based on whatever the user prompt is, like Alice and Baba going to science fair on Friday, then what it's going to do is when it gives you the output, it will essentially have the name here, the date here, and the list of participants here. And that way, this really improves the quality of the output, and you know how to extract what information where. Also, it enables type safety because now these outputs have to stick to a certain structure. So for example, let's say if it had like weight or height, and those could have been strings, but if you enforce it to be integer or float values, then it will stick to that. And so literally you can just copy this and then, format it according to your own needs. And this is exactly what I've done over here. So we'll just use a simple model, GPT-4o, because I want it to not be, the best model. I wanted to make mistakes so we can kind of test our framework, which is another idea, by the way. Like if you build your application with the best model, you don't know if your application is good or the model is that good, right? At least until you write some like really detailed evals and stuff. So always start with like a mediocre model, and that way you can kind of just battle test whatever you're building and then go from there. Anyway, for this planning scene node, the lesson plan node, we're going to write the scene plan response where the plan is just going to be this like storyboard, and it's a string, and basically you can just write the description here. All these things really help the LLMs. Class name, we'll talk about this. This is essentially just the class name that we're going to give in our Manim code. And then there's the reasoning. And so I like to do that every once in a while, where like when I ask a question to ChatGPT, to any of these models, I will ask them to give a reasoning. And often this improves the quality of their output. And so you just, by the way, we're just going to use direct API call. So overall, it's going to be, we have a system prompt, and we'll talk about this in a second. It's pretty long, which I think that people underestimate how prompts, how big the prompt that you can actually work with. And generally, the more detailed you can be and more structured you can be, I think you should. But anyway, we'll talk about that. This is the user prompt where it says like, plan the scene for the following prompt. And this would be whatever the user inputs in the application, like, hey, explain, why grass is green or how the derivatives work, stuff like that. You call the API client, you call the OpenAI client, and then this is the same response structure that we saw in structured outputs over here. And so you pass in the system prompt, you pass in the user prompt, and then in the response format, this is where you enforce the schema that we wrote over here. So when the response comes out, it will contain 3 key value pairs, basically. So it'll be plan, the name of the class, the scene class name, and then the reasoning behind it, right? And so if I run it, you will see that, again, my question to it was explain quantum entanglement. Let's see what's the scene plan it writes now. Okay, the response came back, and this is just the scene class name, and then here's the whole plan. So it says, hey, in scene 1, you should write the text quantum entanglement and put it at the top center with color purple, below the title, do this, put them in these positions, background is black, blah, blah, and this should be the narration. Now, this is not bad. I feel that down the line, you can structure even the scene more. So even these details are structured outputs. But for right now, let's just like go with the simplest thing, right? And so we have this scene, and then it gives you the reasoning, why it selected those kind of animations and objects to show, and how it will explain these things. And then, by the way, we never talked about the system prompt. My bad. So the way I like to prompt it is just 2 or 3 overarching principles. Like one is give it a role, right? So here I say you are a Manim expert and an excellent teacher who can explain complex concepts in a clear and engaging way. Tell it what to do. And because what you're trying to do here is like, you're going to parse the output of this node to another LLM, right? Which would actually implement that in code. So you just tell it who you are, what your role is, and what your task is. That's like the first 2 or 3 things you should do in system prompts or any prompts in general. I go a little bit beyond that and basically just give it a little bit more guidance as to how to break these scenes down. And this was just like a little bit of, my experience with teaching. It's like, hey, you should introduce and explain things with a clear title, 2, 3 key components, give it a practical example, and then summary. And then some of these things are basically things that I have iterated on after dealing with a few problems in the past. And so this is just something that I came up with because I know certain intricacies within Manim. And so I've basically told it to like align these things properly, ensure the scene is not too crowded, just general guidelines. Now, is it necessary that it's going to follow all these things? No. And we're going to have like some like traditional code guardrails to ensure that this, things don't go out of frame, and then the scenes, there's no visual overlaps and stuff. But it doesn't hurt to even give it all that information. The more context it has on what you're trying to do, the better. And then obviously user prompt is just a single line and whatever the user asks it. Anyway, so it gave you this scene. And then the next thing which you're going to do is basically convert all of that output of scene plan into code. And let me come back to what this base class template is in a second, but let me just go down and talk about the next node, which was the code generation node. Again, as before, we're going to enforce a certain schema, and we'll ask it to give out the code. Again, use explanation to be like, hey, explain why you wrote this code. Usually it's a good idea. And then down the line, there might be use for like fixing errors. Right now, it's a little superfluous because for the first time, it's not going to give any error fixes because it doesn't even know it has errors. So essentially, we're mostly just focusing on the code and the explanation, right? I do want to point out that, just because you put the string type here doesn't mean that it's enforcing the model to give out legible code, because anything is a string. My name is a string, but it's not code, right? And the models today are so good that just from reading the code and like the field description, they kind of know what to do. And so most of the times they will write out legible code, but it's not necessary. And so in Pydantic, you can actually have some like external, like these decorators that can validate a certain field for you. And so they will use like abstracts and text tree to parse all of these strings, and then essentially, point out if it's valid or invalid Python code. And then you can have these ways of essentially re-invoking the API, where if this is not valid Python code, then you tell the model like, hey, you gave me the string, it's not valid Python code, write it in a way that it's Python code, and it works out. But for right now, we're going to skip all this complex setups because I just want to keep things simple. And to be honest, most models are good enough that just this is going to work out. Anyway, generate code, again, same thing. We're going to call the API directly. Here, I do the same thing. I give it a role. I ask it what to do. And then now here's one problem with code generation, right? You don't want it to write any code. You want it to write code that follows a certain structure and follows a certain library, right? How do you do that? Now, before you even jump into like, hey, we can use RAG and we can fine tune the model, we can do reinforcement learning. Like, yes, sure, they're all good ideas, but think about the effort required to actually make that happen. An easier way to do things, like you should always think about the low hanging fruit. Easier way to do this is to just give it a code template and maybe give it an example of like what to write, and then see if the model kind of at least follows a similar code structure. And you'd be surprised how good it does just with like 1 or 2 shot examples. Right. And so that's kind of what I've done here is I said like, hey, you're a Manim developer. You need to write completely runnable Python code. And then this is Manim voiceover base is a base class that I wrote manually myself because I have a little bit of understanding how Manim works. And what it's going to do is just import from it and then use the code template to write perfectly runnable code. And it all makes sense as you go down, right? So I give it some requirements. There are certain things that you want to make sure it does right. And then some of these methods I've written out myself because relying on LLMs to make sure that the scene is clear before the next one comes in just by prompting is not good enough. It makes a lot of mistakes. So, when you play with these things, it's always an iterative development. You can ask the model to do things, doesn't mean it's going to do it. And if it doesn't do it, then implement those pieces in actual code so you can programmatically ensure that that's happening. Anyway, that's the whole system prompt. And then what we're going to do is give it this code template, and we'll discuss this in a second. But then this is where the scene class name goes. It inherits from the base class, which is present in this base class template, where I set up the background, I set up the voiceovers, and all that kind of stuff. And then essentially you have these 3 different scenes that come in. And so you have intro and explanation. This is just an example, but if you give that to the LLM, it's going to follow this general structure and then give you code that works. Again, the user prompt is simple: generate Manim code from the following plan. Plan is the output from the previous node. And then again, the same structured output. The response format, you enforce the schema, and then you return the generated code, right? And so let's just run it really quick, but before, let's kind of discuss the base class. So if you've seen any other tools that do the same thing, like, hey, give us a prompt, I'll generate Manim videos for you, I think some of the problems that they face is that often their objects will be like flying all over the frame. And sometimes they go out of the frame, sometimes things overlap. And this is a problem that generally Manim developers solve by kind of knowing the grid layout and essentially just either like iteratively changing where the positions are based on the output, or just kind of defining certain grid points. The way I've done it is write a base class that has a constructor and certain methods that are always going to be included in the code. And those methods are created to do certain things programmatically, right? So whenever it creates a title, the LM generated Manim code, it will always use a create title method. And in here, I have basically ensured that the font size is a certain one. It's buffed like 0.5 from the top. And then it has, if the title width is a little bit longer than the frame width, then scale it to fit the width, and then similarly, there's a method called fade out scene, which clears the scene out. I wrote a couple other methods which ensure that things stay within the frame boundaries. And if they don't, that they should scale accordingly to fit the frame. So, and like to arrange objects if there's like too many objects that are like overlapping each other. Anyway, these are just simple methods to help the LLM structure these objects on the screen properly. Because often it's not going to know what to do, even if you ask it to arrange these things. So it's best if you just like abstract all these things into these like little functions, and then you can ask the LLM to invoke these methods to arrange stuff. And I think it works out better than if you just give it raw instructions on like how to arrange this stuff and make sure that it doesn't fall out of the frame. Anyway, this is the base code template, and then I pass it onto the system prompt over here. And let's just generate the code. The code is generated, and then let's print it out. So it basically wrote this code, and then you can see kind of followed the structure that we talked about. And essentially what we can do now is run this code and see if it runs. So again, we're done with the first 2 nodes. In the third node, we just want to do the execution. And then again, you can enforce a certain schema. You have the output of the execution, and if there are any error messages, that should go here. And you may have to refer to Manim docs to like how Manim is executed, but basically you can pass these like command line arguments, and at least for the sake of this notebook, I'm going to run Manim code in the same environment as the rest of the code. But obviously in production, you can provision a different Docker container or a different environment altogether just to execute the code. But right now, we're just going to keep things simple. First thing we're going to do is write the code into a file, and we'll save that file. And then we will execute that file with Python. And these are some flags P's for preview. So like once it's generated, it'll show you a preview of the animation. And QL is just for low quality. This will be the file path, and you also have to pass the scene class name. And then, not a bad idea to find out, see how long it takes to render this code. And then if it goes through, then that's great. Animation is generated successfully. It'll show you the time it took, and then it will save the video file in the location that Manim usually saves it in. But if not, then essentially what we're going to do is show the error message. And if the error message is very, very long, we'll just print out the first 5,000 characters and the last 5,000 and return all of this execution response, right? So if we have errors, we will see the output of the error. Okay, so let's just execute, and we'll see what comes out of it. By the way, Manim, the Manim edition I'm using is the community edition, and it uses a renderer called Cairo, and Cairo uses CPU to render these videos. And because of that, it's a little bit slower than it would be if it was using GPUs, for example. And that's why even in my alpha that I've deployed, it takes a few minutes to get the video out. But there are ways to use the OpenGL renderer, although it's not straightforward. Once I can figure that out, the video generation will be instantaneous and it won't take a long of a time. It's all on a product roadmap, by the way, which maybe I can share in the next video. But anyway, the result came out, and sort of what you would expect, that such a complicated scene doesn't execute perfectly in the first try. And again, so there's some type error. We had some unexpected keyword argument. This is perfect because I didn't want it to execute perfectly in the first try, because now I can kind of talk about how to recover from this error and how to kind of build this workflow where these errors can happen, and then the LLMs will just self-resolve them. So now that we have the result, let's build the fourth and the final node, which is the error correction node, right? And we'll have essentially three fields here. We'll have the fixed code, again, force it to explain how it fixed it, and then essentially the changes it made. And so in this code, we will have the system prompt where you can give it a list of common Manim errors, and then tell it that you have to preserve the overall structure and the behavior, and then ensure that objects are properly created, all the animations, proper timing, just essentially some things so that while it's fixing what's broken, it doesn't break the things that were previously working. And then again, we'll just be like, hey, please fix the errors in this Manim code. Here's the error, here's the code, here's the error messages. And use, again, the same as before, structured outputs. This time we can try a better model just to correct the errors. And let's run that. And again, here we'll pass two arguments. One is the error that we got, and then the generated code that was there. And then we'll print that out, right? So let's see what that does. Okay, so after a few seconds, you get the error analysis, and it basically tells you what the error was, what changes it made as a result of that. And then what you can do is take the fixed code, and you can print it out and see if it made the changes. And I talked about just to manually verify, but the real check is essentially executing the corrected code and see if it works this time. And it may work. If it does, it'll give you out a video. If it doesn't, then essentially you can kind of run this whole setup again, where you pass the error and the fixed code again to the error correction node, and then hopefully it'll work out. But let's see what happens this time. And then what we're gonna do is essentially just put all those nodes together, and then put in a condition between the execute node and the error correction node to essentially keep running that. Whatever we're doing manually, we'll just automate all of that within just a simple Python function. We don't need to use any kind of complicated framework for that. This is just a simple workflow. And you can orchestrate all of those things manually in just Python code. It's basically a series of if-then-else statements. Now, in the next video, we'll talk about how LangGraph can make these things a little bit better. State management. We'll talk about state. We'll talk about how you can have beyond just a simple if-then-else API chaining. We can create nodes and edges that are dependent on the output of the LLM itself. So there's tons of things you can do with LangGraph, but for right now, it looks like we did one error correction and it worked out. Video. We don't have to watch the whole thing, but you can notice that it kind of all these different things, and you have this video out. Right. Now, we don't need it for this time, but if it doesn't work for you, then feel free to run through this again, and hopefully it works out. Now, this is where I essentially just orchestrate all of those things in just this one Python function, right? So in the first step, you will essentially have the storyboard response, and then this is where you get the whole plan, and then it generates the code. And then here is when you turn the loop on, right? And so you say that, okay, well, we'll put this max version attempts as like, let's say 3 or something, which is passed over here. And we say that for any attempt more than 0, you execute the code. And if the error is not seen in the result, then the animation executed successfully. But if it does, then essentially you try to pass it to the error correction node and fix it that way. But if, after 3 attempts, it still doesn't work, then just break the loop and say, hey, we did not work, blah, blah, failed to fix the errors, right? And that way you can make sure that it's not making infinite calls to the LLMs trying to kind of beat the dead horse. Because generally, if it can fix in like 3 or 4 tries at max, you have bigger problems to fix. But fortunately, even though it's a very simple orchestration and very simple prompt engineering, structured outputs, I think the models are good enough that if you just implement some basic engineering principles, it all works out. And so, yeah, so you can run this function, and then essentially this time you don't have to do anything manually. We'll just ask it a whole different question. So like generate and execute with correction, explain derivatives, and you can run this thing, and it will basically go through all the nodes that we talked about, right? So let's scroll up a little bit. What we have essentially done now is that we have contained all of this operation in that function. And so you asked explain derivatives, it's going to generate a lesson plan. That lesson plan is going to pass down to the code gen with our base template that we created. And then the code gen node will know, okay, I have to explain this concept with this lesson plan and generate a code in a format that's given to me in a code template. And then it'll try to execute it. If it passes through, you get the video. If it doesn't pass through, it will go through error correction 3 times. And hopefully it's able to resolve all those things. So yeah, going back, let's see if it generates. Probably not. It takes, again, as I said, it takes a couple minutes, but I'm sure that if you run it, it's going to work out. And that's pretty much the end of the first video. In the next video, we'll orchestrate the whole thing in LangGraph. And then in the following videos, we'll talk more about how we can strategically implement some pipelines and maybe some external tools to make this workflow even more robust and less prone to errors. Thank you.